Welcome. My name is Mr. Sunarine, and today's lesson will look at how can I apply my learnings from 4th grade to find the area of composite figures. Before we get into today's lesson, we're going to review what are composite figures and ways we can find the area. So a composite figure is a figure or shape that can be divided into more than one of the basic figures. So when we're talking about basic figures, we're talking about squares, rectangles, triangles. But for the purposes of this lesson, we're going to be looking at breaking a composite figure down into rectangles. So here, some information might be missing. So if we're trying to find the lengths of all the sides, we notice that the bottom part is missing and this side is missing. So let's say if we're trying to figure out the bottom part, what we can do is use known information on the diagram to figure this out. So this figure is unknown, but we know that on the top, this is given that it's 8 yards and here is 6 yards. If we put those two together, we'll notice that the whole length on the bottom is 14 yards. Also here, we do not know what this length is, but we can know some other information. We know that this side is 9 yards, so the total is 9 yards, but here is 6 yards, and here we do not know. So what we can do is 9 minus 6, giving us 3, or some number to plus 6 gives us 9, which is also 3. So here we'll figure out this side is 3, and then there we would be able to know all the missing lengths of this figure. I'm going to also review how you can find 2 different ways on how to find the area of composite figures. This first way of doing it is breaking down the figure into two or more smaller pieces. So here I broke it down, I drew a line straight down and broke it down into 2 rectangles. In this rectangle, we know that area is length times width. So what we're going to do is multiply 9 times 8 gives us 72. We're also going to find the area of this figure, which is 6 times 6, which is 36. And in order to get the total area, we want to add the 2 areas together, giving us 108 yards squared. In this second method, what we're going to do is we're going to create a huge figure or a big figure, and we're going to subtract it from the missing space that's provided here. So when we put lines to create a big figure, we know that we would have 9 times 14, which is the whole area of the figure, including the space. And when we do that, 9 times 14 is 126. We want to take the area of the small figure because it is not included, and we can subtract this area with the total to give us our area that's given. So here we have 3 yards by 6 yards. When we multiply that out, that's 18. And when we find out the composite figure, we would get 126 minus 18, giving us 108 yards squared. Still, in both situations, we got the same answer, and there are 2 different ways of getting that answer. Okay, we're going to look at a question. Okay, Emma's rectangular bedroom is 11 feet long and 12 feet wide, with an attached closet that is 4 feet by 5 feet. How many square feet of carpet does Emma need to cover both the bedroom and the closet? So pause the video, think about how you would work through this problem. You may need to draw a diagram, label known information, and see if you can use the methods we talked about to find the area in order for Emma to cover both bedroom and closet with the carpet. Okay, we're going to move on to the next slide. Okay, so for here, we're going to look at 2 different ways of doing this. So when taking the information from the diagram, what I did was create a rectangle that's 11 feet by 12 feet, and then I created another figure that's 4 feet by 5 feet, and I put it next to it. It doesn't matter where you put it. You could put this figure on the bottom, you could put it on next to it. It doesn't matter as long as the 2 figures are next to each other. And what we're going to do for this method is we're going to take the areas of each of the areas of the bedroom and the closet, and we're going to add them up. So this first one, we would do 11 times 12, which is 132. And for this one, we're going to do, for the closet, we're going to do 4 feet by 5 feet, which is 20. We're going to add the two values up, and we have a grand total of 152 feet square. That's one way of finding the area of this composite figure. Another way we can do this is using the same diagram. We can create lines to create a huge figure, and we'll take the area of that, and we're going to subtract the missing area here, and we would get our answer or our area and see and compare it with our original answer here. So when we take the area of the huge figure, we notice that the whole piece is 11 and 4, which is 15, and we have a 15 by 12 area. When we do that, we get a grand total of 180 feet squared. And what we can do next is we're going to take the area of this small white area, which is empty space. So when we do that, this length is 4 feet and by 7 feet, and we're going to do 4 times 7, which is 28 feet squared, and we're going to subtract the two values. The 180 minus 28 gives us 152 feet squared. Therefore, whichever method you use, we still get the same answer. So the answer is 152 feet squared of carpet is needed for Emma to cover both bedroom and the closet. Okay, we're going to look at one more question. Okay, so find the area of the figure below. So again, pause the video, think about how you would work through this problem, maybe find out missing information on the diagram, and we'll compare your answers with the ones provided on the next slide. Okay, so here we go. So in the first method, what we're going to do is we're going to break down this figure into smaller pieces. Here we're used to, in the previous problem, we broke it down into 2 figures, but here we can break it down into 3 figures. So here, before we find the area, we need to figure out missing lengths. So over here we have 5 feet, which was missing, but we could figure that out because the whole length is 15 feet, that's given, and each of these are 5 feet. So 5 feet plus 5 feet is 10 feet. We subtract that from 15, giving us 5 feet. So just in case if you're wondering where we got that 5 feet from. The next value we're going to find is this length on the bottom, as well as this length over here. We know that on the top is 20 feet, so on the bottom is 20 feet as well. But if we need to figure out what this length is, what we can do is, since the whole length is 20 feet, and we are given that this part is 12, we could do 20 minus 12 gives us 8. When we find from here, we could find the area of 3 figures. So the first figure would be 20 times 5, and on the bottom would also be 20 times 5. So each of these would be 100. And in the middle area, we got 8 times 5, which is 40. So we can add 100 and 140, add them up, we get 240 feet squared. For this next method of finding the area, what we can do is close this area, find the area of the big figure, which would be 20 times 15, giving us 300 feet for the whole area. And we're going to take the area of the small area that's shaded in, and we're going to subtract it. So here we have 5 times 12, which is 60. And we can take 300 minus 60, giving us 240 feet squared. So the area of the figure is 240 feet squared, and you'll notice we got the same answer for using either method. Now we're going to move on to our summarization. Okay, so in conclusion, how can I apply my learnings from 4th grade to find the area of composite figures? First, we want to use given information to find out missing sides, and know different ways to find the area of composite figures. Hope this was helpful, and have a great day.